This video is to provide guidelines on how to use the chemical softening, costing, and sizing tool. The tool is divided into 5 different sections. The first worksheet will provide you an overview of the system's or the tool's functionality, what to input, and what to expect as output. The second section, it would provide you some basic instructions on how to use the tool. The third section is a dashboard, which is your main interaction uh, with the tool itself, where you put your input and you would get your output. There's a section about back calculations and informations on how the outputs are calculated and what methods are being used. And finally, the fifth section will provide you with a process flow diagram and what to expect in terms of water quality and flows and mass balance and whatnot, designing the chemical softening unit. The tool is designed for engineers that want some quick calculations of how chemical softening is done, um, and or people who are preparing a proposal, and chemical softening turns out to be one of the unit operations that are trying to propose. Going into these instruction sections, you can clearly see there aren't much instructions. Basically, in the dashboard, whatever cell that you see in yellow you need to fill, and whatever you see in pink are the outputs that are automatically calculated. It provides um, a couple of references where the methodologies has been extracted from. The third source for methodologies here is our own extensive data on actual projects that we have performed and pilots and commercial projects in the past. They are integrated with the information from these two sources to provide the functionalities behind this tool. In the dashboard section, again, basically whatever you see in yellow is an input, and whatever cell you see in pink are an output. Basically, you would input your water quality, which are parameters that are important to chemical softening, total hardness, alkalinity, bicarbonate, carbonate, metallic hardness values, like calcium, magnesium, barium, strontium, and iron, silica, and sulfate. In addition to chemical softening, this tool will also enable you to calculate that what you need to do in terms of desilication using MagOx. So the general inputs here will enable you to define the throughput of the system, the redundancy factor that you want to include, whether you want to do 25% above design or whatnot, daily operating hours, 24 hours or otherwise, annual operating days, the project lifetime, as well as annual interest rate. This unit being used in provide you with some normalized capex cost for the system, the cost of waste disposal, solid waste disposal, the cost of liquid waste disposal, if any, the cost of power. Here you can choose whether you want desilication to be included or not, and also whether you want to use sodium hydroxide as your initial means of softening or lime. Also, whether you want to choose to have post-treatment pH adjustment afterwards or not, because as you know, the immediate effluent coming off a chemical softener will likely have a very high pH. On the output side, it would give you capex in terms of dollar amount, normalized per gallons and per cubic meters, as well as detailed OPEX cost, dollar amount per year, dollar per gallon, and dollar per cubic meters. And finally, it gives you the total cost of the project, normalized basis, as well as the footprint and expected the footprint that you would probably need. In the back calculations, there are a lot of things happening. First and foremost, the tool calculates here the uh, basically the chemical dosing rates in terms of milligram per liter as well as gallon per minute and liters per hour that you would need. It would also takes into some it takes into consideration some removal efficiencies of different components that are in the water and provide you with the actual amount of solid to be expected, uh, as well as the annual rate of consumption for chemicals. It will then take into consideration the cost of those chemicals, the unit cost of those chemicals, and comes up with the OPEX calculations. It would also calculate the amount of specific energy requirements, assuming a 20 psi um, feed pressure, cost of power, um, the solid generation rate, um, total total solids, pounds per year or tons per year, the cost of it, the cost of upkeeping the unit, and the capex, the residence time, clarifier height, opex. Also, it sort of provides you within a sketch um, and some key parameters of on how to size up and cost your filter press effectively. It would you would have to do some inputs, which are pre-assumed here based on our experience, and it as it goes down, it starts calculating all sorts of um, um, uh, operating parameters such as waste generation, the liquid waste that you would need to clean this thing as frequently as you want, the underflow rate, which you make an assumption here again is defaulted at 20%, the feed pressure that goes into it, the specific energy consumption in terms of kilogram per hour per barrel or per cubic meter, the footprint, the capex, as well as the opex for that filter press. Very similar to the dashboard, all the yellow um, cells here are the cells that you can change the 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 input depending on your project conditions. For the sake of argument, if your cost of sodium hydroxide is much higher than that in terms of dollars per pound, you can change it to whatever you want to change it to. And the pink ones are the ones that are calculated using the methodologies defined inside this tool. Uh, Finally, the process flow diagram chart will give you a simplified process flow diagram on what to expect in terms of different concentration of chemicals that you need to use, and basically what sort of mass, flow rate, or that you would need, and it would define them both in imperial as well as SI units. Here, um, it would tell you based on your input of water quality what to expect in the water quality, leaving the stream number the stream number 5 here, which is your final effluent. The calculations here, both in here as well as the back calculation tab, will feed back into the dashboard, providing you with the outputs you need here. Finally, bear in mind that this again is a semi-empirical tool. It takes into account some basic concepts of chemical softening in terms of chemistry, as coupled with our field operating data on various projects here and there, to provide you with a simple and quick tool in order to be able to size up and cost out chemical softening or desilication unit operations. If you have any questions or comments regarding this tool or any feedback on how to improve it, please do not hesitate to send it to this email address, info@pws-water.com. And I hope that you would find this tool useful in your daily operations. And if you have any, as I said, if you have any recommendations for us on how to improve it, please do not hesitate to drop us a line. Thank you.